Hi, I'm Jim Colvin. I'm representing Ultratech, and I would like to tell you about some of the products here for advanced sample preparation. This is an ASAP-1 IPS machine. This is tied into what's called PEEK. This is an electrical endpoint control unit. And so we can get very close to the endpoint on silicon, and depending on the type of silicon you're working with, we can get down to about 0.1 microns resolution. Across the die for our normal curvature modes on this, we're approaching about 1.5 microns across a die of about 20 millimeters across. So we have some new technologies in order to achieve this, and I'd like to just give you a brief overview of this. If you've seen the product in the past, of course each year it's evolving. We're adding more tools and techniques both to the software and to the hardware. So some new features that I'd like to show you this year, one of them is called the surf function. When you're thinning a part, you can deterministically define your grind. But the problem is when you're doing the polish generates non-uniformities in the surface. So we have a positive feedback force system called surf, which defines your surface so that your polish is also defining the contour in that mode. So if we turn surf on, what it's doing effectively is it's creating a feedback loop with the force, and it's pushing up or down against the sample against irregularities that amplifies in the mapping. So this way you get a very beautiful flat contoured surface in order to achieve the 1 or sub-micron resolutions that you're after on the tool. So that's our newest addition. Another very new addition this summer is the tilt table. So traditionally on this unit you had a manual X and a manual Y tilt table. Now we're 5 axes controlled. So the tilt table can be automatically programmed through the software. You just tell it the drop down points you want it to do. It will drop down on those locations and it will measure the X tilt, the Y tilt, and the curvature profile of the device. And then those profiles will show up on this screen here. So these are your parameter curves, which have been here for several years now, that shows X curve, Y curve, and tilt. It's just now it's interactively controlled through the automated tilt table on the system. There are 2 patents that have recently been issued on these techniques. One of them is the thermal control for endpoint, and the other one is the electronic control for endpoint. The thermal control, where this is important, especially if you're doing ultra-thin silicon, when you're down to a micron or 2, there are going to be stress factors in the bumps underneath the silicon. In order to mitigate those, because there is stress from the underfill, we need to be able to take the temperature of the part up to mitigate or relieve the stress, then do the polish, and then when the product is tested, dropping down a sill lens to the visible light sill work that's now being developed. When you do this, you'll have a top and a bottom surface that now is properly contoured to the sample. If you polish at room temperature and then you operate the device where it ends up elevating its temperature, tens of degrees C, you're going to end up with what I call the orange peel effect. So there will be these small bumps or divots over each of the bumps involved with the VGA package, and we don't want that. So this temperature control with closed loop keeps you very locked in, not only to control the curvature, but also to control the local stresses, as well as those global stresses that are caused by the curvature. On the PEEK unit, we have the ability to measure parametrically. So we measure the tip to sample interaction. We look at the VT curves parametrically, or family of curves. And we also can look at capacitive and resistive endpoint. These are 2 papers that we published in 2012. And one of those papers was the award-winning paper for that year. So I'd invite you to review those papers, which were also published to the past in ISTFA. The last brief thing I'd like to cover, we have also modified the system, although I don't have it here, but it's in my talk Tuesday morning. What this does is it converts this head into a probe station. So now you can interactively endpoint mill to target, either on a board or on a die, and you can also drop down micro-position probes to be able to pick up the data interactive to what you're doing with your board. So board level prep, die level prep, basically this is a modular package. You just need to contact Ultratech to explain what your specific needs are. And I'd like to thank you for your attention.